pixel in the output. Okay, so and actually T is what, that I am taking a pixel, I am processing it using T, and I am generating output. But for simplicity, if I am writing like this, because I am going to do that for all pixels, I'm not going to perform it for one pixel, right? Mostly on the entire image. Now tell me, suppose I am using this 255. How this 255 is representing a white or maximum value? Why exactly this 255 number represents a white? What is the reason? Why it is not 128? Why it is not 1000? Why it is not 2000? Why it is 255? Do you remember? How this 255 number came? We were using 8 bits of pixel, right? Suppose I am using 3 bits of pixel, then what will be what number will represent a byte? Suppose yes, 7 is going to represent a byte, true. So what actually we have, that if I am representing using n number of bits, if I am representing my pixel using n number of bits, then 2 raised to n minus 1 or 2 raised to n is L. Right? L is what? 2 raised to n. How many levels I have in my intensity? How many colors I am having in my image? How many different shades of shapes will be there in my image? If I am using n is equal to 3, different shades of gray will be there in my image if I am using n is equal to 3. How many different shades will be there? Shades of gray will be there in my image if I'm using, yes, it will be 8. Right? So L represents the number of levels, number of intensities in the image. Okay, and this number, suppose I'm using n is equal to 8. How many levels I will have? 256, right? And the numbers will be from 0 to L minus 1. 256 levels or 8 levels, but numbers are given from 0 to 7 or 0 to 255, right? So that is what they say here, that number of intensity levels, that is number of shades that are available. How many intensity, what are the values of a pixel? Intensity level is nothing but a value of a pixel, right? Intensity level you should understand as a value of a pixel. So value of a pixel can be just 0 to L minus 1, where L is equal to 2 raised to n, where n is equal to number of bits that you use to represent a pixel. Up to this, anyone is having any doubt? As I told you about spatial filtering, to generate this location xy in the output, I have to use surrounding as well, like this. So to generate this, I will need the surrounding. Okay. Like one of the operation that to generate this value, what I am going to use is average of surrounding. I will use average of all 9 pixels to generate this pixel. That is one kind of operation, right? So many other operations are there. We will see which are those. But one of the possible is that you will find average of 3 cross 9 pixels in the surrounding to get this pixel average value. Yes. Now a question is there to you. Okay. For this pixel, where is the neighborhood? To generate this pixel in the output, I have to use this pixel and its neighbor. How many neighbors I need here? What is the size of the neighborhood that I need? That I have decided 3 cross 3. Okay. So if this is the pixel that I want to generate, that means I have to take 3 cross 3 neighborhood of this. That means if this is a pixel, 3 cross 3 surrounding of that I need. That means I need here this surrounding, right? And of course this surrounding. This is how I will need 3 cross 3 surrounding. Yes. Are you following that? If I am in the corner, I hope you will understand that if I am in this corner, I will, these 3 pixels are there. I need this many other pixels. What to do? What should I do for them? Because for the boundary that is going to create the trouble, I don't have the pixels here. How to take neighborhood? What is your suggestion? What to do? KMF, can you explain that what you want to wrap around? That is what your suggestion is, Arun? Okay. What is see? What is Arun's suggestion? That you just feel like it is wrapped image, and you take this values as this values, and this values as this values. Is that your point, Arun? That is wrapped image. Okay, but it is possible. Let's say yes, that can happen. That is one of the suggestions. See, again, processing. You are free to have your own processing, right? But what can happen? Like I can show you here. See here. Here, see, actually, the surrounding of this, what is expected? Suppose I'm taking this pixel, its surrounding is expected to be black, right? Suppose I'm taking this pixel, if I'm taking rep from this, it is a brighter pixel, and that is going to happen every time. Yes or no? But of course, I'm not denying this is one of the possible method if you want to have like that. But that is not generally preferred. The reason is that not necessarily that left side of your image is similar to right side, right? And upper side of your image is related with the lower side. It is not necessary to have like that, right? So generally, it is not. What will happen like. A drastic difference will come, and if you are having some operation like averaging, these values are going to affect much on this value of computation while processing, right? What I am expecting, whatever ideally near to that values are needed. So what is your other suggestion in case any? Some of you might suggest that if you need these values, fill it with zeros. This is another suggestion. Fill it with zeros. Simplest one, if the elements are not present, consider them 0, right? But yes, this is so that is what also is accepted when that is what we prefer, that is what we do. But again, yes, here it is, if that averaging issue that I stated is going to take place, but this is widely accepted solution. The reason you will understand when you will study that Fourier transform part. Then when we discuss that part, at that time you will understand the importance of this. But I'm so what if missing pixels are there. If you want to fill them, widely accepted solution is to fill them with 0. That means assume that they are not exist. Whichever pixels are not existing, they are zeros. Okay. But yes, Rishi, we are coming to this. Yes, uh, uh, yes, that is yes, Harsh, and mirror the other side. Yes, that is yes, true. All of you are correct. You are pointing to the same. Yes, I was talking about this. This is the best solution that you are discussing with me. True. I'm coming to your point, but let me complete my point here. One of the solution is that filling with zeros. Another solution is filling with 255. Okay, but in both the cases and widely accepted, if nothing is stated to you, you are going to understand padding is done with 0. If nothing is specified, now onwards cases, if I will not specify anything, you will understand padding is done by 0. It has its own reasons, right? Right, so that's okay right now. And if it is specified, so what is other options? Fill it with 255. And what is the best option? That, as you suggested, that mirror the neighbor itself, mirror this row itself here, mirror this one. If I want to pad here, one line is required to be padded, just copy this line and pad it here. Copy this and pad it here, right? So that is what you were suggesting, Rishil, Harsh, Jinal. That is what your point was, no? Or anything else that you wanted to discuss? Okay, and that is the best solution, right? That is the best solution, because here see, affect will be impact of these zeros and bytes, impact of the zeros and 255s will be very less. But again, as told you, if nothing is specified, we are going to work with zeros. Okay. Why? We have a reason. When you will understand in chapter 4 later on. Okay. But okay, we will come back to this partial filtering. But this is what the basic is. What is basic? To generate a pixel, use neighborhood. If neighborhood pixels are not available, then various options are there. Or fill them with 0, fill them with 255, or mirror them. Mirror the last row available, last column available, both of them. Okay, fine. But if nothing is specified, consider padding of 0. Now, now we why we want to study this image processing? Why we are going for this partial filtering and intensity transformation? Because we want to enhance the image, right? Why we are doing this process? Because I want to enhance the image. What is enhancement? Do you know what is enhancement? How do we define enhancement? I say this is enhanced image. Now question is to you: is this which image is better? Which one is enhanced image? One image one or two? Okay, left image you are saying it is enhanced image, right? Okay, because it is present to you, right? But it is possible in some application only black and white image is required, right? So and again, it is possible. Have you ever experienced that you capture a photo, right? And you like it a lot, but your friend or the other person in the photo doesn't like it at all. Have you experienced that type of things? You are or the reverse way that you someone likes that and you don't like it at all, right? So what is my point? Like if I will show you image, right? That is very common thing. Yes, that will happen many times. So what is the case like? Image. If I will show you the image, right? Whether it is good or not, it is quite subjective thing, right? You may like, your other friend may not like. It is possible that some of you like this grayscale left hand side. Some of you may like this black and white, and it is nothing wrong. This is enhanced image. This is edited image. This is we had the process to get that, right? And it is suitable for certain application. That's why we have taken this, right? So image enhancement is quite a subjective process. So here we don't have any objective criteria for now, at least. In future we will have it, but for now we don't have any objective criteria that if this value is greater than 90%, that means it is the best image. That cannot happen. That depends on the subject that uses it. Okay. That's why enhancement, to judge whether it is enhanced or not, which one is good, is very difficult actually. Okay. So what we call, like, image enhancement is a process of manipulation. You will manipulate the image and you will make it to suitable to a specific application. It is more suitable than the original to a specific application, right? It is not necessarily it is pleasant to your eye, right? Here it is not maybe pleasant to your eye is this one, not this one. But in some application, possibly this is the only accepted version, right? So this is your enhanced image. Okay, and even though we are looking for enhancement, like if I'm making it brighter, making it darker, then also that is quite subjective process, that enhancement is done or not. To which extent that enhancement is done is quite a subjective process. Okay, so image enhancement is a subjective process. We will study objective process as well, right? In that you will have a percentage. Okay, if it is up to this percentage, that means it is enhanced. But for now, we are going for the subjective process. Okay, and we have experienced that. That is very common thing that we have experienced, right? Now, we are going for some basic transformation so that we can enhance the image. What are the options that I have? How can I enhance my image? So I have basic intensity transformation to enhance the image, to make it suitable for some application, right? That is an image enhancement. And I have basic operations, that one of them is linear, the second is logarithmic, third is power law. In that linear, I have two options, that identity and negative. Okay. Logarithmic, we will come to one by one. We will go to them one by one. Okay, this is identity transformation where T is defined like this. This is your input, this is your output. What is your expected result? Intensity transformation is what? You take input values, you take output values and modify them like this. This is your T. This is your modification. What is your expected result? Same. What about others? Yes, it is. Yes, it is no change. Same. Yes, it is true, and that's why it is identity transformation. What is that? As it is. You are not modifying. It is 45 degree, right? It is whatever is input, that is output. Whatever is input, that is output. No change. So yes, this is what is there. No, like operation is performed, but there is no change in the output. Is it okay? Everyone is comfortable here up to this? Any doubt in identity transformation? No change in the output because it is like this, right? Tell me about this. What is this? What will this do? This is input, this is output. Yes, Hardik will say it is reverse. Magnitude is same but negative. How negative? Do we have a negative value, Rishi? What is negative here? What is, yes, L minus 1, right? Right. So what will happen? Now tell me in terms of black and white, dark gray, light gray terms. Magnitude inversion and reverse. Input is 0, output is 255. That means input is black, output is, if input is black, output is white. True. Right. It is color inversion. True. That means if it is a dark gray, then input is dark gray, then output will be, it will be a light gray. True. It will be a light gray. True. And black will be white, white will be black. So that is like an image negative, like this. Observe. That is what was expected. White region black, black region white, dark light gray, dark gray, and dark gray, light gray. Comfortable, everyone? Great. So this is what you have to perform in your next laboratory, all these operations on your images. So bring your images. Okay. So what is the use of image negative? See, generally what happens that when we have a tumor detection or some X-ray modifications, X-ray not modification, but actually understanding, or what we should say, evaluation kind of thing of X-ray, right? So what we need, so that what happens that background is dark and foreground is light. Okay. But if we need automation, in many automation algorithms, what they expect that background should be white, foreground should be black, right? So if you want to do that type of operation, if I want to detect certain tumor or certain tissues there, so my algorithm will desire that background should be white. At that time, when my information is embedded in the dark region, this is the information which is embedded in the dark region. I want my algorithm needs that it should be embedded in the lighter region, so that I'm simply going to apply the image negative. What is the equation of that? Whatever your current value is, that should be subtracted from L minus 1. Okay. So if my, suppose it is 3-bit image, and if my value is 3, what is negative value of that image, that pixel? It is a 3-bit image. My current pixel value is 3. Yes, my negative pixel value will be 4. How? L minus 1, that is 8 minus 1, 7 minus 3. Okay. Yes, 7 minus, yes, true. So I think now you understood it, right? So we completed this two, identity and negative. Why it is linear? It is a line, right? It is a line. So it is a linear transformation. Now we are going for the logarithmic. I think now you understood what it will be. Input output logarithmic scale. This scale or in the reverse way. That's okay. How to obtain? Take your input value, add 1 to that, take log of it, multiply with some constant. Constant can be any value, 1, 2, 3, any value of your choice, and generate your output S. Right? How? What is the good value of C? What should be the good value of C? On which factors will it depend? That see what I'm going to do. Suppose any image is given to me, na, that image value I will take, that pixel value I will take. I will add 1 to that. Now let us complete first this. Why to add 1? What is the range of R? What is the possible range of R currently that you know? Yes, log 0 is not defined. True. Yes, it is 0 to 255. Right? It is 0 to 255 currently that you know. I am not saying that every time it will be so. Right? So if by chance that it is not denied na, that R can take value 0, if it is taking value 0, then log of 0 will not define. It is infinite or not defined. And if I'm adding 1 to that, so it is, at least it will make it 0, right? And that's why this 1 is added, so that infinite value or not defined log issues will not come, right? So that's okay, that is fine. Now tell me, what factor should be used? What factors can affect different values of C? One of them is that how much bright or how much dark you need. Suppose if I'm using higher value of C, then what will happen? It is going to make my image brighter, right? Smaller value of C will make it darker. So again, application is the required one. Application is a required one. A thing that decides that. Okay. One more thing is uh, again subject who looks at that. It is possible that with a particular value of C, I like it. With the other particular value of C, I may not like that. That depends on the subject who will judge that. Okay. So C value can take any value. That depends on several factors like the application, like the subject that that observes it, the judge, we can say. So we will see the impact of that C in the laboratory. Again, once again, that is a part of laboratory, but logically you can understand, I guess. Otherwise, you can, of course, you can try in Octave and you can check that. So this is what the log transform is. Now, what kind of image will it generate? Observe this. Observe this, take and tell me whether the generated image will be brighter or darker. If this is a log transform, that input values, this input value will get mapped to this input value will get mapped to this, right? Right? And this value will get mapped to this value will get mapped to this. This is what is that. Yes, it is brighter. What is the reason that it will be brighter one? Why do you think it will be a brighter one? Small value of R, S value is more. True. Dark is becoming bright exponentially and bright is remaining almost as it is. True. I will redefine it. I think the words are given already here. The narrow range of low intensity is mapped to a wider range here. and the wider range of bright intensity is mapped to narrow range here. Let us go to in more detail. A narrow range of low intensity is mapped to wider range. That means it will include the brighter intensities as well. Of course, darker and the brighter. Brighter intensities are remaining brighter, right? And the narrow range as well. So that's why, yes, true. All of you are understanding it correct, and that's why it will give us a brighter one. Now, one more thing. Suppose one more point is here. That is, it is a dynamic range compression. What is that? Okay. Now, now we see, or what we have, that we have the monitors, right? We have the monitors that displays the image, right? Our monitors are designed to display the 8-bit representation of image. If it is RGB, then that 8-bit, 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 otherwise 8-bit. Okay. What is the meaning? That, see, our eyes are not responsive to all the colors, and that's why 8-bit representation is fine. If I am dividing the available color range into 256 shades, it is more than enough, right? So one thing that my monitor is limited to, that it is not needed, even that 8-bit representation is sufficient enough. Okay, any value goes beyond that, what will happen? Suppose so now my monitor is what my monitor will show. If my image input value is in the range of 0 to 255, it will show accordingly, right? But if my input value goes to 300, suppose anyway, if I'm giving as image value is 300, and if I'm giving it to monitor, what is the job of monitor? To display. What it will display? It will display a pixel in the range of 0 to 255. So what will happen to this 300? Where it will, which value for, which color for this 300 it will show us? Which color for this 300 it will show us? Yes, it is going to show us 255. So can I say, actually I am losing this information? I am losing this information, right? I am losing this information, right? So from it is 300 or 301 or 305 or 330, everything is mapped to 255, right? And this, what I told you is very smaller range. In certain operations, when we will go for the frequency domain, at that time, your after processing, your R might take values from 0 to 10 raised to 6. Why, how, what is the importance will come later, right? But right now, assume that, suppose it is possible that my values are the values that I am taking is from 0 to 10 raised to 6. Okay. So what will be the what? So it is going to create the trouble. There is a very dynamic range that I have. I am not able to. I see what will happen from 0 to 255. I am going to retain certain information only. 0 to 25. How many? How much information I will have? Very less, because my total range of available information is 0 to 10 raised to 6, right? So in that information I will get as it is from 0 to 255, which will be very less percentage of the actual image, right? So actually I am going to lose most of the information from the image, because rest of the pixel will be truncated to certain value. Okay. So that's why I will not prefer to use this input values as it is. So what I will do, I will apply log transform of that on that. Suppose I am applying log transform, and suppose my R value takes 10 raised to 6. 10 raised to 6 plus 1 is almost 10 raised to 6, right? And then suppose I am taking log and C value is 10. What will be my S value? Suppose it is base 10. Otherwise it is my natural log, but for simplicity assume it is base 10. So 10 raised to 6 log 10 raised to 6 will be, yes, it will be 16. Huh? True. And that is how that C is going to affect us, right? You can take C is equal to 10, 20, 30 according to your requirement. So now S will become 60, corresponding to what? This 10 raised to 6. According to, by adjusting C, you can adjust this value as well. So now for 0, can you tell me what will be S for R is equal to 0? What will be S for R is equal to 0? What R is 0, then yes, it is going to be a 0. So now my range from 0 to 10 raised to 6 is now 0 to 60, right? Again, based on C, I can adjust this properly. So can I say I compressed my dynamic range? And that is what the dynamic range compression is. And by what is the advantage of this? The advantage is that hidden information is visible now. Whatever the information that was hidden, that was suppressed because of extra available values, is now in the this computable range, and hence it is visible. And overall look, so this is what I was talking about. If I am taking log transform, image will be brighter as expected, and it is going to show us some hidden information which was compressed, suppressed because of this dynamic range available. Okay, so this is what the advantage of a log transform you have. Is it clear, or everything is clear to you about this log transform? Any doubt that you have? Okay. Now tell me regarding to anti-log transform. It will be this shape. This shape. What will be the outcome? It will be brighter or darker? If this is my transformation, overall outcome will be brighter or darker? Yes, it is going to be a darker one, right? It is going to be a darker one. So now you will keep in your mind, if this type of shape is there, then means it is a brighter outcome. This shape, brighter outcome. This shape, darker outcome, right? So I was talking about this. We completed negative, we completed identity, we completed log, we completed inverse log or anti-log, right? So anti-log, again, that you can that is inverse log is also known as inverse log. Okay. Now we are going for the power law transformation. What is how to obtain power law? So power law has this equation: S is equal to C into R raised to gamma. Okay. So C is a constant that depends on your application. You can choose is as per requirement. Gamma is also application dependent. Gamma and C both must be positive. Gamma can take a positive value. It can take a greater than one value, less than one value, and equal to one value. Okay. Suppose C is equal to 1 and gamma is equal to 1. Which transformation it is? Yes, it is identity transformation. So this curve is for, assume C is equal to 1 for every case, right? Right now, assuming C is equal to 1. So if gamma is equal to 1, then it is identity transformation. Okay. Now, this is what I was talking about. It is an identity transformation for gamma is equal to 1. If gamma becomes less than 1, shape becomes like this. Gamma goes greater than 1, shape becomes like this. Assuming C is 1. Okay. Tell me, for gamma greater than 1, image will be darker or brighter? Gamma less than 1, image will be darker or brighter? Greater than 1, less than 1, darker or brighter? We concluded here something. This shape becomes, yes, it is, yes, yes, greater, that means darker, less than, that means brighter. I will come to this two slides, we will go to that, but let us complete. If this is my image, right? Okay, I want to look at this information available. So I should make my image what? Brighter. That means my gamma value I should use should be, what should be it? It should be, as you suggested, less than 1. And yes, so less than 1.6 is used, zero point 0.4 is used, and zero point 0.3 is used. 0.6, 4, and 3. And you can see the information is now visible. Okay, so it makes it bright. Now, same way, if you want to go here, this is washed out image. I want to enhance it. What should be my gamma value? Greater than or less than 1? I want to make it, um, yes, it should be greater than 1. The gamma value should be greater than 1. 3, 4, 5. It is 3, 4, 5. Okay. Now you may ask me that logarithm also enhances and makes it brighter, darker. This also makes it brighter, darker. We are adding 50, 30, 20 linearly. Last time we did in the laboratory and we obtained it. And it was also making brighter and darker. Which method should we use? Which method is best method? Which method is best one? I told you earlier. What is the reason behind? Because it was studied last. Because we studied it last, that's why. So that we can do with logarithm, even that we can do with adding, suppose I'm adding 20 instead of 30, right? That I'm controlling that, na? Yes or no? So what I told you earlier, data loss, yes, that can be one of the factor. That can be one of the factor. Yes. See, data loss is one of the factors that can decide that what, suppose I have a large dynamic range, right? And possibly if it is in few ranges, then possibly gamma is not helping me much. Then I may go with the log. Otherwise, it is going to perform the same task as it is performing in here, right? What was the case here? That again, this is subjective process. All of them are working for the same, right? You can, this is just a trial and error. You can go with any of the method available. If it is working, see, is what happens if some of you will say, okay, if I'm going for the log, but it takes a lot of computation because I have to find the log of it, and then I have to multiply, or I have to go for non-linear operation like taking a power. It is possible that in certain algorithm I don't prefer to have this type of non-linear operations, that is in some system it is not supported, right? So I may not go for this, and I may simply go for 30, adding 30, 40, 50 kind of things, right? So again, none of this method, you cannot compare them like just which one is best, which one is worst. It is not the case. You can have, like, if I have a huge dynamic range, then I should not definitely go for that subtracting 10 raised to 6 out of all. That should not happen, right? Or 10 raised to 5, 35 out of all kind of thing. That should not happen. So for that, I will either choose power law or log, that depending on the application, right? or if it is a very smaller images, like it is instead of having range of 0 to 255, it is having range of 0 to say 260 to 70. Then I can go with the simple linear operation by subtracting, adding, because it is quicker, right? How much data loss is accepted, because here see, the logarithm I have a fixed curve that will either for the natural it will be different, for the log base 10 it will be different, right? But I don't have much flexibility. That flexibility is available in the game. Someone of you, like Rishil, I think that is what you wanted to say. I agree with you here. I agree with you here. You, if this was your point, like flexibility, we are getting in gamma. I agree with that. Okay, so so again, that is what my point was. And again, if I am choosing this gamma 0.20 or someone chooses 0.25, 0.25, right? So both of them are going to give you more or less same results. Whichever suits your application, whichever suits the judge, that is what the method we should opt for. All of them are good methods. Which do we have any objective method to decide? No. That's why it is a subjective process. How to decide which one to use? Trial and error. Is the point clear to you? Up to this, everything is clear to you? Should I go to the next point? Great. Great. Now I am going for one more point. What happens? See, earlier we were having that CRT monitors, right? That huge monitors we were having, that cathode ray tube based monitors. Okay. Now, what was happening in that if this is the image that I want to display, what is my expected? This is the input to my monitor, right? If this is the input to my monitor, what I am expecting, this should be the output in my monitor. Whatever I expect, that type of output should come, right? But what was actually happening? Actually, that was displaying me this type of image. Monitor was displaying me this type of image. Why so? We will discuss it. Right? It was displaying me this type of image. Like you will feel like original image is modified using it is darker now. Original image is darker now. You will feel like original image is gamma transformed by gamma greater than one value. That's why it will become a darker one, right? But what is my desire? That I want this type of image. So what I will perform? I will perform gamma correction. What is that? Take your image first, don't give it as an input, right? Perform gamma correction first, that means make it brighter. Whatever this value was, that value should be like, if it was 2, it was like I'm giving you the proper value. It was like uh, it was 2.5. Suppose it was 2.5, gamma greater than 1. You will feel like it is gamma transformed by gamma value 2.5. That's why it is darker one, right? So what you will do first? You will perform gamma correction. You will make it brighter by how much value? By which value of gamma you will correct it? You will correct it by 1 by 2.5. Yes, you will correct it by 1 by 2.5. And that will be what? How much? 1 by 2.5? It will be zero point 0.4. Right? So it will become brighter. Yes, it will be 0.4. So it will become brighter, and then give it to monitor. What monitor will do? Whatever is input, it will gamma correct. It will perform the gamma application. I mean gamma transformation with 2.5. So actually you will feel like it. Actually you applied this, then your monitor applied this. So actually you got this transformation, intermediate transformation, which is nothing but your identity transformation, and hence whatever was input is appeared as output. Okay. So in short, if it is making bright, if it is making dark, make your image bright first, correct it in the gamma, and then give it to monitor. That is what was required to perform. And this is what is gamma correction. Why we need it? So see what happens, that ideally what was desired, that if whatever voltage, what we desire, that whatever intensity is generated by CRT should be in proportion to the voltage that we are providing, right? So this image is provided in terms of voltages, right? So what was desired, that light intensity that is generated should be in proportion to the input voltage. But because of electronics used there, that was not possible. They were getting it like whatever intensity is generated, which was almost 2.5 times of, or it was like the power of input voltage raised to 2.5. That was intensity was produced. We are not going to understand that electronics of this CRT tube round, as it is not even at all used, right? It is very rare now, right? So generally intensity generated was not what I want. Whatever input voltage is provided, according to that output intensity should be generated. This is what my desired one was. That is, input is equal to output, identity transformation. But CRT were generating it like 1.82 input voltage raised to 1.82 input voltage raised to 2.5. That was a range of intensity it was generating. That was a fixed value. Whatever it was, that was a fix for the given monitor, right? Now, so if it is suppose 2.5, then actually you will feel like output is gamma corrected by 2.5, or rather output is gamma transformed by 2.5. That's why what you have to do, you have to correct your image first by applying gamma 1 by 2.5, and that is what is 0.4. And so first you will apply gamma correction, that is gamma transformation intentionally you will do. You will make your image brighter, and then you will give to monitor. Monitor will perform again a gamma transform, default one, not desired one, but it is there, and that's why you will get your finally your output here, and which is same as your input. And this is what gamma correction is. One of the application of your gamma transform. One of the application of gamma transform. Is it okay? Is it clear to you? Now, piecewise, any doubt in gamma correction? Should I explain it again, or should any information is required here? Any information is required? Okay. Okay, that's good. Now we will go for piecewise linear transformation in the next lecture.